Okay, so we need to look for the time, right? So now we are going to list our values that we have. Remember, when you work with free fall, always you're gonna use the gravity. So it's our first value. What is the gravity? Or it's the acceleration when you fall an object.
9.8
9.8 meters per second square. Okay. Now, the other value that we have here is the distance. We represent with the letter X. Look, X is equals to what?
8.52.
8.52 meters. Then we need to look for time, right? Which is our missing value. Okay, we have gravity, we have distance, and missing time. Now you're gonna go to the kinematic equations and you have to try, according to the information that you have to look for what of these one is correct to use. Which one do you think? The number 1, the number 2, the number 3, and then or the number 4. What do you think?
I think the number 3.
Number 3? And what do you think, Victor? Victor?
How?
Fabricio said that it's number 3 that we have to use to solve this problem. Why, Fabricio? Could you tell me why?
I think because we have the velocity.
And the initial velocity, we already know that it's 0, right? When you fall an object. So look, we have distance, which is X. We have the time, that is the number that we need to look for. We have the acceleration, which is gravity, and the time that we need to look for. Okay, and what is the initial velocity? What is the initial velocity? 0, right? So in this case, you can put it here, the initial velocity, which is 0, okay? So that information, you can add it also. So we put B sub 0, okay? So we are gonna use the formula number 3 to solve this exercise. So we put X. If you want, you can put this little triangle, which means the change,
Delta.
okay? Or delta. It's Greek letter. So B sub 0 multiplied by the time plus 1/2. Oh, okay, another thing, look, if you want to work easily with this, you can put 0.5, okay? Or you can work as a fraction. If
Why, miss?
What?
Why? 0.
Because 1 divided by 2, it's 0.5 as a decimal. The acceleration, you already know, and then t squared. Okay, now it's time to replace value. What is the value for X?
8.52.
8.52 meters. Well, now remember this one represent meters. The initial velocity, what is?
0.
0. M multiplied by the time that we don't know, right? Plus 0.5. What is the acceleration?
9.8 meters per second.
9.8 meters per second. Square, right?
Mm.
We close, look, and what is the time? Square. Remember, the time square is the value that we are looking for. Okay? Now, look, before to start solving with this, we need to try to delete the 0 multiplied by t. What is?
0.
0, right? So we will have just 0, or you can delete the 0. Okay, because the 0 you can cancel like this. Every time that you have a quantity multiplied by 0 doesn't count, so you can delete, okay? Because 0 plus any number is the same number. Now, look at this. We need to look for the time, okay? So what do you have to do? Wait, it doesn't work this. Okay, what do you have to do with the 0.5, which is multiplying with the t squared? How do we need to pass it?
Dividing.
Divided, exactly. Wait, people, give me a moment. We need to pass to divide. So you will copy 8.52 meters 8.52 divided by what? This is multiplying past 2?
0.5.
Uh-huh. And
Equal,
also look, the 9.8 is multiplying with t. How do we need to pass it?
Divided.
To divide, exactly. Meters per second squared. Then I will tell you, if you want to use only the number and then replace just the units like meters and seconds squared, you can do it, okay? And look, we have t to the second. So now please divide 8.52 divided by 0.9 times 9.8, please.
1.73.
1 point.
73.
Okay. Now, wait, 1.73, right?
Mhm.
In this case, we will have meters per second.
So that is the
No,
time.
second square. No, this is not a time. Look, here we have t to the second. Did you remember how to eliminate the power of 2? What do we use to eliminate the power of 2? How do we eliminate the power of 2? What is the inverse operation? You don't remember?
Dividing.
No, the power of 2, we use square root.
Ah, yes, but
1.73 seconds squared equal t squared. Look. Now we cancel the power of 2 with the root and then take please the square root 1.73 and give me the answer.
1.31.
1.31.
1.31 equals to time, seconds, right? Seconds.
So
And
that
this
will
is-
be the time.
This is the time.
Mm.
And this is the answer. Now, what I told you people, if you want to put the units here, like meters per second, you can do it. But if you want to use only the numbers, you can do it. But at the end, always write the units, okay? Always write the units at the end. If are seconds, meters, meters per second, so you have to write it. So to answer this problem, we have determine the time required for the shingles to reach the ground. The time to reach the ground, what is?
9 point. No, 1.1.
1.31 seconds.
Sorry, 1 second. Look. Did you understand?
Yes.
And that's all with this. With this problem, we finished. And the second one. So the idea, Diego and Victor, is to list first the values and then look for the specific formula. Okay. So now we are gonna do the second one. Read the second one, please, Victor.
Rex thinks throws his mother a crystal base vertically upwards with initial velocity of 26.2 meters per second. Determine the height of the to which the base will rise up above its initial height.
Initial height. What is the velocity?
26.2 meters per second.
Meters per second. Meters per second. Okay, what another quantities do we have, or what value do we need to look for?
Height.
We have velocity and we need to look for the height. Remember the height we represent with the letter X, right? What another quantity can we use here?
Initial height.
What is?
Initial height.
Initial height, no, because remember we need to look for the height. If we had the initial velocity, what velocity do we need to look for?
Acceleration.
The acceleration also? which is 9.8 meters per second square. Okay, now having these three values, velocity, initial velocity, gravity, and we need to look for distance. What formula do we need to use? Look, I will put it here. Look, we X we need to look for. We have velocity and we have a gravity. Analyze which one of them.
Number 4.
Question, the number one, can we use the number one?
Yes.
Yes.
Why yes?
No.
No, because here, look, here we have
have
time, and
time.
in the problem, we don't have time. The second one also, you cannot.
I think that the fourth one.
The 4th one is
Yeah, the number 3, you cannot because we don't have time. The fourth one, exactly, the number 4. So we put velocity square equal initial velocity, which means v sub 0 to the second, plus 2 times acceleration times x, okay? So what is this value that we have the other velocity? What will be our other velocity? This one.
26.2.
No, this one. The initial
Oh.
velocity was 26.2, but this one, the velocity took 0,
0.
0, exactly. So we put the other, or just replace by 0. So this one, the initial velocity, what is?
26.2.
26.2, and this is raised to the second. Look, in this case, I will not write the unit. This b to the second, b sub 0, what is?
0.
0. Gravity, what is?
9.8 meters per second square.
9.8 meters per second square, or in this case, we will write only 9.8. Because
Why?
I think when you write the units like meters and seconds square could be confused for you. Okay?
Mm.
That's the only reason. But if you want, you can write it. 26.2 to the second, what is?
606.44.
600.44.
86.44.
Okay. And the 0, remember, nothing, right? And 2 times 9.8, what is?
19.6.
19.6. X, look. Remember, we are looking for X, or it's a for the distance. So this 19.6, it's multiplying. How do we need to pass it?
Divided.
Divide it, exactly. Or divide both sides by 19.6. It's like a linear equation, look. We cancel and we get distance equals to what? Distance equals to what? Divide these two values, please.
Gravity.
No, divide these two values.
35.6.
35
Yes,
point.
35.02.
Mhm.
02.
0.2, like this.
2. Yes.
X. And this, that's what I told you at the end, look. If it's distance, it's meters, seconds, meters per second square, or meters per second. If it's distance.
Meters.
Meters, right? So we put the meters, look. That's what I tell you, that if you want, you can put only the numbers and at the end, just copy the unit, okay? So did you understand the number 2?
Yes.
So what will be
Yes.
the answer?
35.02 meters.
Yes. So we have the height of the height to the base will rise above the initial height is 35.2 meters. That's the answer. And look, that's all. How do you think this topic? How do you see this topic? Is easy or complicated?
No, it's medium.
Easy.
It's just to identify the specific formula. Okay, this one. Read it, Fabricio, please.
A stone is dropped from the top of a cliff. It is seen to hit the ground below after 3.50 seconds. How high is the cliff?
Okay, what values do we have here? Give me the values that we have here.
Yeah.
Velocity.
Time.
A stone is dropped from the top to the cliff, so down, right? If it's seen to hit the ground after 3.50 seconds. So this is time, right?
Time.
In the gravity, 9.8.
Exactly. Remember, always we use gravity, 9.8 meters per second square.
Square.
Okay.
We have
And
to find the height.
height, so X, look. What formula can we use?
The 4
Let me copy this.
and
Wait. Wait, let me copy the formulas again. Here we have the formula. Now analyze. Look, we have time, gravity, and we need to look for X. So this one, the number 4, we because we don't have velocity. Number 3, can we use number 3?
I think the number 1.
Number 1, but number 1, we don't have velocity.
number.
Number
Yes,
2.
can be number 3.
Number 3, right? What will be our initial velocity?
0.
0.
0, exactly. What is the acceleration? Here we have, look.
9.8.
What is
9.8.
the time? Here we have, look, 3.50. And we are gonna look for X. So we are gonna use the number 3. Remember, you can replace the 1/2 by 0.5. So it's time to replace values. The X we are looking for, right? Initial velocity, what is? What is it?
0.
0, right? What is the time?
3.50.
3.50. What is the acceleration?
9.8.
Yeah. And what is the time?
3.50.
3.50, but in this case, raised to the second. Okay, multiply 0 times 3.50, what is?
0.
Yeah. We have 0. Now, 3.50 to the second, what is?
12.25.
12.25.
0.25.
Okay. Now, multiply, solve this one, 0.5 times 9.8 plus 12 times 12.25, please.
60.025.
60.025. And this is given in meters, seconds, or what units?
Meters.
Meters. And that's all, look. Did you understand? Look,
Yes,
in this case, it's easier because we don't need to isolate anything. Okay. So the distance, how high is the cliff? The cliff is
60.025
meters height. Exactly. The cliff is 60.025 meters height. And that's all. Any questions?
No.
Okay, the last one. We are gonna copy the formula, read the problem, please.
A coin is tossed vertically upward and reaches a maximum height of 0.90 meters before it comes back down. With what velocity was it thrown and how long was it in the air?
Okay. I think in this problem, we need an extra information. Let me analyze the problem. I cannot read. A current shows the vertical upward and reaches the maximum height and before it comes back down. With what velocity? No. In this case, we only have one quantity. So let me see. We have the maximum height, we have gravity, and we need to look for velocity. Yes, we can solve it because we have two questions here. We need to look for velocity and then we need to look for time. Give me the values that we have here, please.
Height,
Mm-hmm.
0.9.
The
0.90 meters. The gravity, which is?
9.10 meters per second.
And we need to look for first in the first questions for
Ah,
velocity, right? Okay, so what formula?
The thing, the sec, no,
the fourth,
Look, we have
no,
X,
because
we have X here, right? We can use 2, 3, or 4 because in the first one, we don't have a time. In the second one, we don't have time also. Number 3, we don't have time, right? Yep. And number 4, we have velocity, we have, yeah, number 4. We're gonna use number 4. Okay, here. It's time to replace values. B sub 0, what is? Or initial velocity,
0.
what is? 0, right?
0,
Acceleration,
9.8.
9.8,
9.8, remember is the gravity. And the displacement or the time, B or the distance?
0.9.
0.90. Okay, here we have 0 plus 2.9 times 9.8 times 0.90. Do it, please. See, remember, this is multiplication. 0 plus 9.8 times 0.90.
17.64.
You got the same, Diego?
yes,
Okay, now, how can you eliminate this power of 2?
Square root.
square root,
Remember, if you have a power of 2, you need to eliminate. So we put b squared, and in the other side, we also take the square root 17.64. Take the square root, please.
4.2.
4.2.
2.
Yes. So look, we already have the velocity. Meters per second, right? Because it's given in velocity. So look, we already have the velocity. Now, the second question is, how long is in the air? We need to look for time. When it's how long is time. What formula can we use? We already have velocity, look. We have x, which is distance, gravity, and now we have velocity. We need to look for time.
number 2,
And what happened if we use the number 1? Can we use
Yes,
number 1?
I was thinking, yes.
Can we use number 1, or we can use number 2 also, right? But
Yes,
number 2 is gonna be a little bit complicated because you have this fraction, look. Okay, number 1, we're gonna use number 1. P equal B sub 0, wait. What is B sub 0? Or initial
0.
velocity?
0.
Plus acceleration times time. What is the velocity that we already have it in the previous problem?
4.2,
4.2. equal to 0 plus acceleration, which is 9.8. And we need to look for time. Look. Okay. Now we have 4.2. This 0, remember, we eliminate because 0 plus any number is the same. So you will have equal 9.8 t. For what number do we need to divide both sides?
4.2.
4.2.
Sure.
No, 9.9.
Yes, 4.2 divided by 9.8 here. And in the other side, we do the same, 9.8 over 9.8. And here we have t. Look, we cancel time. And what is this answer?
0.42.
0.42.
And this is seconds, meters, or what?
Seconds.
Second.
Equals to time. Look. That's all. We already answered both questions. Did you understand?
Yes.
Yes.
Okay. So that's all for today. Now you can start working.